Hello, scholars. Welcome back to Master the Motion. I'm Sir Isaac Newton, your guide. Until now, we've explored physics in a perfect, frictionless vacuum, a beautiful world where objects slide forever. But look around you. The universe isn't a frictionless void. It is messy, sticky, and resistant. Today, we escape the vacuum to meet the forces of real-world resistance, friction and drag. Let us start with friction. Why does a sliding book eventually slide to a stop? To understand this, we must zoom in. Far beyond what our eyes can see, down to the atomic scale. No surface is perfectly smooth. At the microscopic level, even glass is full of jagged mountains and deep valleys. These microscopic imperfections collide and lock. This locking is what we call friction. There are two main phases of this grip. First, there is static friction. Static friction is that stubborn, silent force that resists the initial push when any object is completely at rest. Once you push hard enough to break that initial microscopic lock, the object finally begins to slide smoothly forward. Now, kinetic friction takes over. It is the resistance experienced by objects already in motion. Crucially, static friction is almost always stronger than kinetic friction. Starting is always the hardest part. As these microscopic valleys grind against each other, mechanical energy is converted into thermal energy. Yes, friction creates heat. It is how our ancestors sparked fire and how your car brakes work. But what happens when we move through fluids, like water or the very air we breathe? This is fluid resistance, commonly known as drag, and it behaves very differently. Unlike dry friction, drag depends heavily on how fast you are moving through the fluid. At low speeds, drag is gentle, but double your speed, and the drag force quadruples. This leads us to a remarkable phenomenon, terminal velocity. Let's look at a skydiver. As they jump, gravity pulls them down, causing them to accelerate, but drag pushes up. The faster they fall, the stronger the upward drag becomes until it matches gravity's pull. When these forces balance, acceleration stops. The skydiver falls at a constant terminal speed. Without friction and drag, we couldn't walk, cars couldn't stop, and rain would hit us like bullets. Resistance is not just a nuisance. It is the very mechanical grip that keeps our world stable and controllable. Keep exploring, stay curious, and I will see you in our very next lesson as we unlock the mysteries of circular motion.